Hello students, so let us continue with the topic. Let us start with the equivalent conductivity. Equivalent conductivity, or we will say equivalent conductance. Equivalent conductance. Okay, so as the name suggests, no, this is related to the one equivalent of a substance. Okay, not like now we will discuss next is what is molar conductivity. So equivalent conductivity means the electrolyte that you taken is 1 gram equivalent. So the conductance offered by 1 gram equivalent, that you can simplify it, that is what equivalent conductivity is all about. So remember, an electrolyte is taken in a suitable solvent, and the amount of substance that is always be fixed, that is fixed into 1 gram equivalent. Okay, so whatever the concentration that you taken, conductivity divided by this concentration, that gives you the equivalent conductivity. So we fixing the concentration, we taking 1 gram equivalent of a substance. So let us define what is equivalent conductance. It is the conductance offered by 1 gram equivalent of 1 gram equivalent of an electrolyte, 1 gram equivalent of an electrolyte in solution. So that we can say it is a equivalent conductivity or equivalent conductance. Okay, so all about how much conductance offered by 1 gram equivalent of substance, that we can say equivalent conductivity. So now how can you find the concentration? We represent equivalent conductivity like this. Okay, we can say lambda eq. Eq stands for equivalent. This is not equivalent conductivity. Okay, so lambda equivalent, which is equal to K, that we studied yesterday, K by C, where K is the conductivity. K is the conductivity and C is the concentration of the solution. C is the concentration of solution. This equation we can use to find the equivalent conductivity or molar conductivity. This is the general equation we will use. Since this is an equivalent conductivity, instead of C we have to use N. N stands for normality. So normality is one of the concentration term, right? 1 second. So let us now rearrange it. So lambda equivalent, which is equal to kappa divided by n, where n is the normality of the equation, normality of the solution, normality of the solution. So this is the way you can find equivalent conductivity. So now we know conductivity. Now try to remember the equation. Equivalent conductivity. We know R is equal to rho into L by A. And if you take the inverse, 1 by R is equal to 1 by rho into A by L. Just to find the unit of conductivity, I just using this. Okay, we know 1 by R is nothing but unit. 1 by R is conductance, right? 1 by R is conductance, so represented as G. 1 by rho is nothing but our conductance or kappa into A by L. So now let us try to find the unit of conductivity. So conductivity K, which is equal to L into G divided by A. Now just I am trying to find the unit. So conductivity we can express length. Generally we express in centimeter. So centimeter into conductance. If the unit of resistance is ohm, unit of conductance will be ohm inverse. So ohm inverse divided by A. Now its area, so it will be centimeter square. So centimeter by centimeter square, you will get centimeter inverse. So unit of kappa, unit of conductivity is ohm inverse centimeter inverse. That is the unit of conductivity. Okay, so please remember that. So we express conductivity, no, conductivity in the unit ohm inverse centimeter inverse. So let us try to find the unit of equivalent conductivity. Trying to find the unit of equivalent conductivity. We know what is normality is all about. Normality is no, it is a number of gram equivalent of an electrolyte or solute divided by volume of the solution. Volume of the solution. Okay, this is the unit of normality, number of gram equivalent. How will you find the gram equivalent? Number of gram equivalent will be equal to number of gram equivalent, which is equal to what's the mass of the substance that you take? Mass of substance, mass of the solute, let me say, divided by equivalent mass. Mass of the substance divided by equivalent mass will give you the number of gram equivalent. Okay, so if you will get number of moles if you divided by mass of the solute divided by molar mass, that is no, we will say that is the number of moles you will get. Here no, we express in equivalent, so means no, you have to divide it by equivalent mass instead of molar mass. That's the only difference. So please remember this is something that you studied in the solutions as well, right? So what's the unit of normality? I can say no. Let me express the unit of gram equivalent as equivalence. Okay. And volume generally expressed in liter. Okay, in liter. And here now we have a unit for conductivity, that is ohm inverse centimeter inverse. That's the unit of conductivity we express, right? So now we can express liter in centimeter cube, where now we know 1000 centimeter cube is equal to 1 liter. That's something we have studied before. 1 liter is equal to 1000 centimeter cube. So now let us express liter in 1000 centimeter cube. So what will be the unit? Unit of lambda equivalent. We can say I put the unit ohm inverse centimeter inverse. That's the unit of conductivity divided by now normality in gram equivalent. So equivalent divided by liter, right? Volume in liter means no, I can write 1000 centimeter cube. 1 liter in 1000 centimeter cube. So this will come upwards, no, you will get ohm inverse centimeter inverse into centimeter cube into 1000 divided by 1000 divided by equivalent. So we got a unit for lambda equivalent. So the equation now just modify if you express in terms of centimeter. So unit of lambda equivalent we expressed in unit in, that will be ohm inverse centimeter cube, which is equal to centimeter square equivalent inverse. That is the unit of lambda equivalent. Okay. Now since we are expressing centimeter, 1000 will also come. So our equation just modifies here. It will be lambda equivalent, which is equal to kappa, that is conductivity into 1000 divided by normality. This will give you the equation for equivalent conductivity. All we need, you need conductivity, you need normality. If you have these two values, you can find the equivalent conductivity. So remember, we express the unit lambda equivalent in ohm inverse centimeter square equivalent inverse. Okay, ohm inverse is nothing but Cman. That's another way we will express. Whenever you see ohm inverse, sometime we will express in Cman. So unit we can say Cman centimeter square equivalent inverse. So you can express, that's another unit of equivalent conductivity. Okay, so please note that. That's very important. Similarly, so we discuss equivalent conductivity. So, but no, more often we use the next term that we will say molar conductivity. We express molar conductivity quite often. So let us discuss what is molar conductivity is all about. Molar conductivity. Molar conductivity, that is lambda m. We express in lambda m. It's a Greek letter, okay. So lambda m, which is we can say just like equivalent conductivity, instead of equivalent here 1 mole of an electrolyte. That's only different. So the conductance offered by 1 mole of an electrolyte in a solution, we can say that is the molar conductivity. So quite often we use molar conductivity. Okay. So lambda m is the conductance offered by 1 mole of an electrolyte in a solution. That is what molar conductivity is all about. So just like the way we found the equivalent conductivity, here now only difference will be lambda m, which is equal to conductivity kappa divided by either molar. Instead of normal, you can use m stands for molarity. Molarity is the number of moles of solute per volume of the solution expressed in liter. That's what molarity is all about. So we express, instead of normality here, we express molarity. That's only different. Okay, nothing much to differentiate between two. So similarly, if you now try to find the unit for lambda m, similarly you can do lambda m will be equal to ohm inverse centimeter inverse divided by, here instead of gram equivalent it will be mole divided by mole per liter. Liter you can express in 1000 centimeter cube. 1 liter is 1000 centimeter cube. So lambda m, which is equal to, have an equation, kappa conductivity into thousands divided by m. Generally we use molarity. Also you can express in molality as well. So I am expressing molarity. So K into 1000 divided by m is our molar conductivity equation. So unit now again, unit of lambda m will be equal to, just we found it will be ohm inverse centimeter square, because the centimeter will come up, and mole inverse. We know ohm inverse is Cman, or now you can express Cman centimeter square mole inverse. That is the equation for molar conductivity. So both equation you will remember, because now the calculation part we will use this. Okay. Now let us try to find a relationship between equivalent conductivity and molar conductivity. So we have an equation lambda equivalent, which is equal to 1000 into kappa divided by n. We have an equation lambda molarity, which is lambda m molar conductivity, which is equal to 1000 into kappa divided by m. Okay, so let it be equation 1, let it be equation 2. Let us find a relation between lambda equivalent and lambda m. So you divide lambda equivalent divided by lambda m, or no? Let us do the other way, because now priority I am giving to molar conductivity. Lambda m divided by lambda equivalent, which is equal to, you divide this by this, 1000 into kappa divided by molarity divided by 1000 into kappa divided by normality. Okay, so lambda m by lambda equivalent, this part will cancel. This will come up, which means no, let me write, n normality will come up, normality divided by molarity. So lambda m divided by lambda equivalent is equal to n by m. N stands for normality of the solution, m stands for molarity of the solution. Okay, so let us now find one more relationship. Now we know what is normality, we know what is molarity. Normality will be no number of gram equivalent per volume of the solution. Number of moles divided by volume of the solution. That was molarity is all about. So it's all about no. If you want to find a relationship in terms of equivalent mass and molar mass, still it is possible, because no number of gram equivalent is equal to mass of the substance divided by equivalent mass. Mass of the substance divided by equivalent mass. Right. Similarly, molarity is again the mass of the substance divided by molar mass. So if you have molar mass, if you have equivalent mass, still we can find a relationship between lambda and lambda equivalent. Molar mass will come up and equivalent mass will be down. So the equation will be, if you have a molar mass, so how it's fun? It was no lambda equivalent mass was down and molar mass will be up, right? So molar mass divided by equivalent mass. Let me check. Molar mass into equivalent mass will be always equal to lambda m into equivalent mass. Okay, or no, molarity into lambda m, molarity into lambda m will be equal to equivalent mass into normality. So that's the way you can find a relationship between these two. Okay, either you remember one of them, lambda m divided by lambda equivalent is equal to n by m. If you have the relationship, you can find the ratio between lambda m and lambda equivalent. Okay, so please note down. Now let us discuss one important point now. We are talking about an electrolytic solution. We passing electric current through it, right? So that's the way we are trying to find the equivalent conductivity or molar conductivity. So the important point here, when you passing an electric current, never use DC current. DC current should not be used. Instead, we should use AC current. You have to use alternating current rather than direct current. Something that you have to remember, because DC will cause decomposition of the solution. It will cause decomposition of the solution. So net effect, we are actually getting a different result rather than the expected result, because now this direct current passed through the solution, it will cause polarization and a back potential will be generated. So now we are actually getting a unexpected result. So always use AC current, that will know, because two cycles are there, so always polarization developed will be in almost nil. So polarization effect won't be there. So please try to understand. Always know the current preferred is DC current. Current preferred is AC current, not DC current. DC current should not be used. AC current should be used. Let us do one problem related to this. The resistance of 0.1 molar solution. The resistance of 0.1 molar solution. Resistance of 0.1 molar solution of an electrolyte in a conductivity cell. I am writing the important part only. Conductivity cell containing two platinum electrode at 4 centimeter apart. And 10.7 centimeter square. 10.7 centimeter square in area. Was found to be, resistance was found to be 70 ohm. Calculate the conductivity and molar conductivity. You asked to find kappa, you asked to find molar conductivity as well. So this is the question. What are the data given? Data given, a resistance is given 70 ohm. Solution is, concentration of the solution is given 0.1 molar, and A, that is area, 10.7 centimeter square. Length is given 4 centimeter. So how can you find the conductivity and molar conductivity? Now for finding molar conductivity you always require conductivity. So let us try to find the equation. Now this is now something either you can derive, that I know shown yesterday and today as well. So what we can do, at least you remember one equation. For example, for me it is very easy to remember. Conductivity is equal to kappa is equal to G into G star. That's something that I can remember, where G is the conductance and G star is the cell constant. So conductivity kappa, which is equal to G into G star, conductance into cell constant. So here now you can find conductivity if we have conductance, if we have cell constant. Cell constant is not directly given, but length and area given, so cell constant can be found. Cell constant, which is equal to L by A, which is equal to 4 by 10.7. If you do, now unit also need to apply, because this is centimeter, this is centimeter square. So that's the way you can find cell constant. Okay, conductance is required, but resistance is given. 1 by R is conductance, right? So let me apply directly. Conductivity kappa, which is equal to, instead of G, conductance, resistance is given, so 1 by R will be conductance. 1 by R into cell constant, that is now 4 by 10.7. So just let me apply. 1 by R is, now R is given, so 1 by 70 into 4 divided by 10.7 will give you conductivity. Remember, always unit should be expressed. If you calculate, you will get an answer that is 0.005340 ohm inverse centimeter inverse. That's the unit of conductivity. Don't forget that unit has at least half a mark. So please write the unit after finishing the calculation. So we found conductivity. So conductivity is done. Then we can find molar conductivity. Molar conductivity is equal to K into thousands divided by M. Molarity is already known. It is given 0.1 molar. So apply here 0.005340 into thousands divided by 0.1. If you apply it, you just apply, you will get an answer which is equal to 53.4. Unit also important. Ohm inverse, centimeter square, mole inverse. So that's the final answer you're going to get if you apply it. Okay. let us do the next problem. You know, I'm only writing the important part of the question. You read it completely. The specific conductance of a m by 10 solution of KCl at 291 Kelvin is 0.0112 Siemens centimeter square. So specific conductance is nothing but kappa, conductivity, okay. Sometime another name they will express. Conductivity is given 0.0112 Siemens centimeter inverse. That is the value that given for conductivity. Then concentration they express. Concentration in molarity is given. So m is equal to, now 1 by 10, m by 10, m means no nothing but 1 by 10, right? So it's nothing but 0.1 molar. So concentration is given 0.1 molar, and resistance is also given. Resistance is R is equal to how much? 55 ohm. 55 ohm. That's the data they given. Now what they asked to find? Find the cell constant. Cell constant is asked to find. Okay. So we have an equation, conductivity K is equal to conductance G into G star. So G star is a cell constant. So G star needed to find kappa divided by G, where no conductivity is already given, right? 0.0112. You write the units as well. Divided by G. G is the conductance. Instead of conductance, resistance is given. So 1 by 55, right? So it will come up. So cell constant will be 55 into 0.0112. Unit will be centimeter inverse, because now cell constant have a unit centimeter inverse. So the final answer, if you do it, it will be 0.616 centimeter inverse. Let us do another calculation. This time now the data that is given, the resistance of 0.05 normal sodium chloride solution taken in a conductivity cell is found to be 203 ohm at 18 degrees Celsius. The cell constant of the cell is 0.9715 centimeter inverse. Calculate the equivalent conductance of this substance. So here now concentration normality is given 0.05. That's a one data that is given. Normality is equal to 0.05 normal. And resistance R is equal to 203 ohm. That's another data that is given. Okay, temperature is 18 degrees Celsius. Then the cell constant G star is also given. Cell constant is 0.9715 centimeter inverse. Sometime from the unit you will understand what they actually mean. Sometime question may be not correct. Still you can understand from the units. Okay, centimeter inverse means that is the unit of cell constant. The question is they ask you to find lambda equivalent. So lambda equivalent, we have equation. It is conductivity into 1000 divided by normality. So we have normality. We want to find conductivity. So conductivity we already know. Conductivity is equal to nothing but it is the conductance into cell constant, that is G star. Conductance is not given but resistance is given. So 1 by 203 into G star. G star is also given 0.9715. That is our conductivity. Find the value. You will get 0.00478. 00478. Express the unit as well, ohm inverse, centimeter inverse, 00478. That is done. Now just apply in this equation lambda equivalent, which is equal to that is kappa 0.00478 into then 1000 divided by normality is given 0.05. Okay, so that's all about equivalent conductivity. You express this, you will get an answer 97.72. Unit is important. Ohm inverse, centimeter square, equivalent inverse. So that's our final answer. You have to practice problem. That's your duty. No, practice yourself. Learn one by one. Next problem, the conductivity of 0.1 molar KCl solution. No, there is 0.1 molar KCl solution having a conductivity, that is kappa of 0.1 molar is given, that is 0.0101289 ohm inverse, centimeter inverse. That's the conductivity value they given. Okay, conductivity of 0.1 molar KCl solution at 25 degrees Celsius is given, and it has a resistance 192.3. Resistance R is equal to 192.3 ohm. That is a resistance also they given. Taken in a conductivity cell. Okay, a 0.01 molar solution of another electrolyte X, when taken in the same cell, okay, same conductivity cell, offer a resistance of 250 ohm at 25 degrees Celsius. Temperature remains the same. Calculate the molar conductivity of 0.01 molar solution of X. So now here data is given. This is for 0.1 molar KCl. Okay, now another data given, this time what's the data given? Resistance is given. Resistance of another electrolyte, let it be X. The resistance is 250 ohm, that is given. Concentration is given, that is 0.01 molar, that is also given. And you have to find the molar conductivity. Molar conductivity of 0.01 molar KCl solution. That's our question. What's the point here? We actually finding the molar conductivity in the same conductivity cell, which means cell constant will be constant. That's something that you can remember when you do such calculation. So how can you start? And all you need to find the cell constant. We know conductivity kappa is equal to G into G star. So G star will be equal to conductivity divided by G. So conductivity we have 0.01289. This is I'm talking about the first solution. Divided by conductance is inverse of resistance. 1 by 92 means that will come up 192.3. So the answer will be the cell constant. You're going to get 2.479 centimeter inverse. So that is our value for cell constant. So we got cell constant, that's good. Now if you want to find the molar conductivity, we have to know conductivity into 1000 divided by M. M is there 0.01. K we have to find. K again you can find conductivity. K is equal to G into G star. We got G star now. So G is the instead of conductance, G is 1 by R. So 1 by 250, that is 250 is a resistance. Into G star we already got right now 2.479. So that will give you conductivity. Okay, conductivity you will get around 0.09916. That is a conductivity you are going to get ohm inverse, centimeter inverse. So that is conductivity for it. So we found conductivity, now easy to find molar conductivity. Molar conductivity will be equal to conductivity into 0.00916 into 1000 divided by concentration, that is 0.01. If you apply it, you will get 991.6 ohm inverse centimeter inverse. That is the, sorry, ohm inverse centimeter square, because we are talking about no molar conductivity, right? Ohm inverse centimeter square mole inverse. That is the final unit. Unit always you have, no, you have to check and no, make sure it's correct. Cell constant in centimeter inverse. Conductivity ohm inverse centimeter inverse. Molar conductivity ohm inverse centimeter square mole inverse. Equivalent conductivity ohm inverse centimeter square equivalent inverse. So that's the way you have to verify the units as well. So what's the difference in this problem was, now here two solution is given with a different concentration. First one was 0.1 molar, another one was no 0.01 molar. So what is the molar conductivity of the second solution is asked. There now we know we using in the same conductivity cell, which means now cell constant will be same. So first you find the cell constant from the first solution. Their conductivity and resistance is given, so I found what is the conductivity first. So once you got conductivity, yes, now you can apply once you got conductivity, once you got cell constant, you can find the conductivity of the second solution, where conductivity is equal to G into G star. G is the conductance. Resistance is given, so 1 by 250 into 2.479. That is the cell constant we got. So you get a conductivity first, conductivity of the second solution. Once you got conductivity, lambda is equal to cell constant, sorry, conductivity into 1000 divided by molarity. Molarity is given, so you will get an equation. Okay, so it's very important you have to practice such problems. More problems you get, you have to do yourself. Okay, that's your responsibility. So thanks for listening. So let us wind up today's session. We will meet in the another section. Thank you.